Dairy processing is usually considered as one of the largest industrial food wastewater source. According to Food and Agriculture Organization FAO 2019, Malaysia is one of the greatest milk importer countries. Each step in the dairy chain, including production, processing, packaging, transportation, they do affect the environment. The dairy industry uses processes such as homogenization, pasteurization, chilling and heating, which involves the processing of raw milk and transforming into many dairy products such as sour milk, yogurt, cheese and many more. Generally, there are three major categories of wastewater in dairy industry. The first one is processing water, which is used in cooking and heating process. It has minimal pollutants and can be reused. However, it needs pre-treatment for applications in area that does not require direct contact with the product. The next category is cleaning wastewater. It usually comes from washing equipments. The effluents are in large quantity of milk and manufacturing residues. Cleaning wastewater are highly polluted and requires further treatment. The last category is sanitary wastewater. It is found in laboratories. The composition is similar to municipal wastewater, and this sanitary wastewater is generally piped directly to sewage works. In this presentation, we are going to focus on the cleaning wastewater in dairy industry.
Dairy industry is not commonly associated with severe environmental problems. However, we must consider its environmental impact as dairy pollutants are mainly of organic origin. Waste from dairy processing industry will contain high concentration of organic material such as protein, which is casein, carbohydrate, lipid, and high concentration of suspended solid. Here are several types of contaminants from dairy industry, which are milk receiving, whole milk powder, cheese or whey or curd, and lastly butter or ghee.
So, the type of contaminant can be sourced from the milk receiving. It can be result from tank, truck and storage tank washing, pipeline washing and sanitizing. It also contains milk solid, detergent, sanitizers and milk waste. The second type of contaminant can be from whole milk powder. This contaminant mainly produced during cleaning operation, especially when different types of products are produced in a specific production unit.
So, for the third types of contaminant is cheese, whey and curd. The waste is mainly result from the production of whey, wash water and curd particles. Cottage cheese is more fragile than rennet curd and it will produce more fine particles if we use mechanical washing processes. And lastly, for the butter or ghee, the butter washing steps will produce wash water containing buttermilk. So, to reduce the potential of waste load from the butter or ghee is to eliminate the buttermilk production and the washing step. Here is the composition of milk processing influence of every dairy product. So as we can see is that the wash water will affect a lot, especially on the pH, BOD, COD, FOG and TSS compared to the others.
Hello, I'm Akila and I will explain about on-site pre-treatment option in dairy wastewater treatment. So there are 4 main points here which I will have. First, physical screening, second pH control, third is flow and composition balancing, and the last one is fat, oil and grease removal. The main purpose of screening in wastewater treatment is to remove large particle or debris that may cause damage to pumps and downstream clogging. Also, there are certain precautionary measures should be taken to prevent the settling of coarse matter in the wastewater before it is cleaned, which are include the ratio of depth to width of the upper channel to the screen, 1:2, and the velocity. As what we can see in the table here, there are large variations exist in wastewater pH from different dairy factories. Therefore, there are different cleaning strategies that can be employed, such as alkaline detergents and also acidic detergents, and both have different functions. Optimum pH range for biological treatment plants is between 6.5 to 8.5, and if extreme pH is used, it will cause detrimental to any biological treatment facility. And usually, flow balancing and pH adjustment are performed in the same balancing tank. pH adjustment and flow balancing can be achieved by keeping effluent in the balancing tank for at least 6 to 12 hours. So during this time, the residual oxidants will react completely with solid particles and neutralize the cleaning solutions. Besides, the usage of mechanical aerators is also important in the system to obtain proper bending of content and to prevent solids from trapping. Another critical factor is the size of the balance tank, where it should be large enough to handle a dairy factory's daily flow pattern at peak season. The last pre-treatment option is FOG removal. FOG can be removed by three systems, which are dissolved air flotation, or by gravity traps, which using the gravity suppression to remove the FOG layer, or by using enzymatic hydrolysis.
Dairy wastewater is generally treated with biological methods such as activated sludge process, rotating biological contactor, sequencing batch reactor, and continuously steep tank reactor. First, let me explain about activated sludge. In activated sludge reactor, aerations and mixing can be provided by pumping air or oxygen into the tank. The microorganisms oxidize the organic carbon in wastewater. The flux which formed in aerated tank can be removed in the secondary clarifier by gravity settling. Some of this sludge is recycled from clarifier back to the reactor. RBC is a fixed filling reactor that consists of a series of circular discs of polystyrene or PVC. The functions of RBC is reduce organic matter. The microorganism present on this will absorb organic matter when they are in water and obtain the required oxygen for them to grow when these are out in water. Sequencing batch reactor is modifications of activated sludge process. In this process, the oxygen is added to aeration system to reduce the organic matter. Lastly is the continuously stirred tank reactor. Liquid waste stream enter the reactor and treated by anaerobic suspension bacteria. The majority of silver solid is converted into biogas, which reduces the solid concentrations in the waste stream. Here are the comparisons of biotreatments.
Moving on, we will take a look on other treatments done in dairy wastewater. The first one is land treatment. Interest in land applications of waste is also increasing as a direct result of the general move of regulatory authorities to restrict waste disposal into rivers, lakes, and the ocean. There are a few reasons on why land treatment is the preferred method in treating dairy wastewater, such as nutrients such as nitrogen and phosphorus that are contained in biodegradable processing wastewaters make these wastes attractive as organic fertilizers. The high cost of incineration and landfilling makes land treatment the more economical, friendly method. The last but not least is irrigation. Irrigation is an action to supply water to land or crops to help growth, typically by means of channels. Considerations on the condition of the wastewater have to be taken. For example, suspended solids in the wastewater can cause nozzles to be clogged and render the soils impermeable. If the wastewater from the dairy industry have extreme pH or high salinity, it will lead the soil dispersion to happen. It is a condition in which the soil is vulnerable towards erosion. And lastly, fats, oil and grease that comprised in the wastewater may be resistant to degradation.
Preventive measures can be taken to reduce water consumption and contaminants in dairy wastewater. Collect and reuse the wastewater for the lower grade products such as in animal feed. Segregation of effluents from sanitary installation, processing and cooling system helps to facilitate recycling in wastewater. Regular maintenance of fitting, valve, seal and equipping filler with drip and spill saver helps to reduce spillage and prevent build-up of millstone deposit. Make sure to run the operation to specified length to prevent the blockage in tube, high pollutant and time-consuming to clean. Treat solid residue as solid waste instead flushing it down to the stream with water. Install a reverse osmosis system to reclaim milk solid from the first rinse water in equipment and pipelines. Example of prevention in butter product is scrap manually to the accessible area after production helps to reduce the amount of cream and butter from entering wastewater stream. In conclusion, dairy processing plays a big role in contributing to the source of wastewater. Dairy wastewater is white in color and has an unpleasant odor and turbid character. The profile and capacity of the company, the production technology, the loss of raw materials, the type of equipment used, the degree of wastewater reuse, influence the concentration of polluting dairy effluent. The main problem of this dairy wastewater is that it is highly polluted with organic and volumetric load, and this leads to the increase in temperature, variable pH value, high COD, BOD, FOG, nitrogen, and also phosphorus. So the drawback of dairy wastewater is the sewage pipe might be clogged due to the low concentration of settable solid. It requires periodic cleaning with appropriate chemical and bacterial preparation, and this contributes to the high cost in manufacturing. A good preventive measure, proper treatment, innovative and more compact equipment should be designed to meet the challenges associated with the wastewater treatment limitation and meet the water quality